Hi everybody, welcome to the first section in Calculus 2. This is a recorded video, so I will go rather quickly. If you need to pause the video in the middle, please do so. And also, this is what I wrote from last semester, and so I write out everything. This will take a little more time, so I will decide that for recorded video, I'll just go over quickly. If you need to, just pause the video. Right, so the first section, we will do a review in Calculus 1. So basically, in Calculus 1, there will be two things. Most important, derivative and integral. And in Calculus 2, we have go deeper in the integration and application in integration. And as you see, on that side, there's the formula. We have derivative and then integral. Right, so the first part of it, derivative. So all of the basic rules of derivative, the power rule, x to the n will be n times x to the n minus 1. So the derivative, note that there's the notation, proper notation. And on the trig, derivative of the trig functions, exponentials, and logarithmic function, product rule and quotient rule, right, like that, all over there. We also have the inverse trigonometric function. We don't need to memorize this. We don't need to memorize this part because that is section 7.5. We will go to that section right after this. Right. Of course, the most important rule in derivative is not in here, which is the chain rule. Right. So let's go to the first example. Now find derivative of the following function. So we have negative 3x to the fourth plus square root of x minus 1 over x squared. So all of this, if we write all of them as the power of x, square root of x is equivalent to x to the 1/2 and minus 1 over x squared, that is x to the negative 2. So two things that we use here. First, the radical form. This is the review, so we write quite a few things here. Right, let's say we have base b to the power of m. Index of radical is n. That will be equal to b over m over n. So we will write square root as 1 over 2. And negative 1 over x squared, we'll use this formula. So negative exponent, where we write reciprocal, the power turn to positive. So cross the line, change the sign. Right, now we haven't done any derivative yet. We just rewrite the function. And now we take derivative. So we do not write equal all the way. So we say the function is equal to that. Then the derivative equal to, right, the power rule. The first one here, over there. So we'll just take the power rule of this term, x to the fourth and then x to 1/2 and x to negative 2. So derivative of this, we take the fourth down, so negative 3 times 4, negative 12 x cubed. And then take out the 1/2 x, 1/2 minus 1 is negative 1/2. So take out the power, original power, minus 1. 1/2 minus 1 is negative 1/2. And then we'll take out the negative 2. Original power, negative 2 minus 1 is minus 3. So we have negative 12 x cubed plus 1/2 x to negative 1/2 minus the negative is plus 2 x to negative 3. And we can stop like that, or if we want to, we can also rewrite this as this is negative power moved down to the bottom, and the bottom becomes 1/2 positive, and then this moves down to the bottom. The 2 will be on top, x move to the bottom, turn to positive, and finally x to the 1/2 we can rewrite that as 1/2 x to the 1/2 equivalent to square root of x. And so we have 2 over x cubed. So the answer can be this form, this form, or this form. It doesn't matter. All of them equal to the derivative. And so that's the first example. Next we have derivative of, try to find derivative of 3x times sine x. So we have 3x times sine x. So this is a product. We will use the product rule. So I will write out u equal to 3x and v equal to sine x. Then we'll take derivative. Derivative of 3x is 3, and derivative of sine x cosine x. So that is the function, it's a product. So when we have the derivative, right, and also the notation for derivative, I prefer to use just the prime sign instead of, you can also use dy over dx, which is the same thing. Right, so derivative, the function is a product, so I will have derivative of the product, and the product rule, actually it is, yeah, there. But instead of write in the f of x times g of x, I'm just going to write the product rule, uv plus uv, derivative of the first, derivative of the second. So this is the product rule. Yeah, like I have here too. Right, and now we just substitute in what we have. U prime, that is 3 v sine x plus u, which is 3x, and v prime cosine x, and let's multiply it out. We will have 3 sine x plus 3x cosine x. Right, so just a product rule, straightforward. Right, next we have derivative of this. So we have derivative of cotangent. Derivative of cotangent, that, yeah, over there. Or derivative of cotangent is negative cosecant square. But that is only cotangent of x. This is cotangent of something else. So in that case we have to use the chain rule, which we, like I said, is too important and too fundamental. So that's why I did not put on the formula over there. Right. So I have cotangent of something. So what we do here is I'll put the parentheses around the argument or the angle of the cotangent, which will have a parentheses here. So when we take derivative, that has the parentheses like that. Derivative of cotangent of something, so it doesn't matter what inside the parentheses. I just say derivative of cotangent is negative cosecant square. Doesn't matter what is inside the parentheses. But the chain rule say doesn't matter what it is in the parentheses, but we have to take derivative of what inside the parentheses. So doesn't matter what inside the parentheses, that is what we have for the chain rule. So derivative of cotangent and then derivative of the parentheses, multiply them. Right, inside the parentheses is 7x squared minus 4. And so when we do that, we just have negative cosecant square of 7x squared minus 4. This one doesn't have any derivative, so I just rewrite it. And derivative of 7x squared minus 4, that is 14x. And derivative of negative 4, derivative of constant is 0. So that's what we have. So that the only thing we can do here is 14x. If there's one term here, I'll take the minus sign and the 14x, put them together. We have negative 14x and then cosecant square of 7x squared minus 4. So that's what we have for that problem. Right. Like I said, if you need to pause the video, you can do that easily. Right, moving on. Next we have this. So e to the sine x plus 4 minus tangent x. Notice that the tangent x is not on the exponent. It is just a separate term. Right. So also we will need the chain rule here. So if I put the parentheses around the exponent of the sine x plus 4, so I will take derivative. So we take derivative. And so doesn't matter what inside the parentheses. So I have e to something, exponential function. So e to the x is e to the x, the same thing. So the only function of that kind. Right. So derivative of e to something is the same. So we take derivative of e to something is the same thing. And then chain rule say always multiply by derivative of the parentheses. What inside the parentheses doesn't really matter. So sine x plus 4 sine x plus 4. Right. So we took care of the e to the sine x plus 4. Minus tangent x. Derivative of tangent is secant square. And there's a minus, so there. Right. Now e to the sine x plus 4 cannot really do anything with it. And then derivative of sine x plus 4, derivative of sine x is cosine x. and then just minus secant square, and then we don't really need to write the parentheses here if we write the cosine of x in front of exponent. So let's just write this as cosine of x, and then times e to the sine x plus 4 minus secant square of x. So pretty much just that. Next we have ln of 4x cubed minus 2. So what is the derivative of ln? The natural log. Derivative of natural log is the reciprocal function. So, but first, the argument of the log is something else. So I just put the parentheses around this and ignore what inside. Derivative of ln is the reciprocal function. Doesn't matter what inside the parentheses. And chain rule say multiply by derivative of the parentheses. Right, inside the parentheses is 4x cubed minus 2 so we have that, which gives us 1 over 4x cubed minus 2, and derivative of 4x cubed minus 2, derivative of 4x cubed is 12x squared minus 2, derivative of constant is 0. And so we're going to put 12x squared on the top. And 4x cubed minus 2 at the bottom. So derivative of ln is the reciprocal function. Right. Next we have this. Right, cosine cube of 2x minus 3. Right. So the cube here actually is the cube of the cosine. So the first thing we do is we need to rewrite this as cosine of 2x minus 3 and then the cube here I can write on the outside like this. So that is equivalent to cosine and then cube. Right, so just rewrite the function. Haven't done any derivative yet. Now we will take derivative. Just like what we did before, doesn't matter what inside the bracket. Derivative of something cubed is going to be 3 times the bracket original power minus 1. 3 minus 1 is 2, and then derivative of the bracket. Right. Doesn't matter what inside the bracket. But we have cosine of 2x minus 3 right. Now cosine of 2x minus 3 square, you can just put the 2 here, just like what we did over here. So 3 times cosine of 2x minus 3, and the square here you can just going to put right there. Right, now we take derivative of inside the bracket. Derivative of cosine something, again we can just put parentheses around this. So derivative of cosine of something is negative sine of the parentheses and derivative of the parentheses. So that is the be careful, I will put the parentheses or the bracket around it. So it is multiplied to a negative sign. Right. Inside the parentheses, 2x minus 3 . Right, so we will have 3 cosine square of 2x minus 3, and then just keep the bracket here, negative sign of 2x minus 3, and then 2x minus 3 derivative of that is 2. Or negative 2. So 3 cosine square of 2x minus 3, and then the bracket, negative 2 sine of 2x minus 3. And finally, when we multiply it out, 3 and minus 2, that gives us negative 6. And we have cosine square and then sine. That's what we have for that one. Next we have y equals square root of secant x minus 5. So square root of something. So similar to what we did before. And we put the parentheses around the secant x minus 5. And then when we have the square root, it will be equivalent to secant x minus 5 square root equivalent to the 1/2 power. Right. So we write the problem like that. Next, derivative of that is 1/2 parentheses, doesn't matter what inside, original power minus 1, and then derivative of the parentheses, doesn't matter what inside, which is 7x, secant x minus. Right. And so we will have that derivative of secant. Derivative of secant is secant tangent. So we have 1/2 secant x minus 5 to the negative 1/2. Derivative of secant x is secant x tangent x, and derivative of 5, that constant. Once again, if there's just one term together as a product, I'm just going to put that in front, and we don't need the parentheses. So we'll have 1/2 secant x tangent x, and then secant x minus 5 to the negative 1/2. Right, so that is that. Next, write out the note. So what we write out the note here. So the chain rule certainly works. but we'll see this a lot in Calculus 2 and later on. We just have derivative of, instead of sine x, we have sine of kx. So for this note, let k be a constant. For a constant k, so we will write derivative of sine of kx is going to be equal to derivative of sine cosine and then k. So it's just a chain rule. So it will be k cosine of kx derivative of cosine of kx is negative sine, but there's a k, so we multiply to it. And then derivative of tangent is secant square. But there's a k, so we're going to put the k. Right, so that, and then derivative of secant is secant tangent and then multiply by k, so k secant x, but it will be kx instead, secant tangent, and then cosecant will be negative k cosecant cotangent, right? Derivative of e to the, oh, we still have cotangent. Derivative of cotangent is negative cosecant square, but there's a k in front of it. And then e to the kx is e to the kx. The chain rule say multiply by k. Right, so all of them we multiply by k. Right, last one. What happens if we have derivative of ln of kx? So derivative of that is going to be the reciprocal function 1 over kx, and then multiply by derivative of the parentheses is k. K and k cancel out, so that gives us 1 over x. So all of this derivative just multiply by k, except for the ln. K and k cancel out, we just have 1 over x. So that is the first part of this review, the derivative. Next we'll go to the integrals. Right. Once again, the formula is over there. So we have the power rule. So increase the power, divide by the same thing, except if n equal to -1, we cannot divide by cannot divide by 0. If n equal to -1, -1 plus 1 is 0. We cannot do that. Cannot divide by 0. So when it is -1, we use different rule. That. Right. And then we have trig function, derivative of the trig function. This pretty much go in reverse. So compared to the derivative of cosine, derivative of sine is cosine, so antiderivative of cosine is sine. So pretty much I just derivative and antiderivative, and then of course plus c, so we'll have all the antiderivatives or the integral, right? And then all the function we have tangent, cotangent, secant, cosecant. We have this. Like I said, this is the review from calculus 1, so we'll not go over how do we have these things. And exponential function is that. The only thing missing from here compared to what we have earlier for the derivative is the log. We do not have the integral of the log yet. So don't worry. We'll learn about that in calculus 2. Right. Of course, if we have definite integral, we use fundamental theorem of calculus, and so just that. Right. Now, let's go to the example. So, first thing what we have here, I'm going to rewrite the function. The integral will stay the same, so I still have the integral sign and then dx. Inside we write the power of x squared. The cube root is x to the 1/3, because here we have x to the first power, and then the index of radical is 3. So that's what we have. And then 5 divided by x. Yeah, we can write, just keep it like that, or we just bring that up, that 5 to the x to the -1 dx. And now we'll just integrate. I will do that term by term. Integral of x squared, power rule, x to the 1/3, and x to -1. So 4 x squared, derivative of x squared is x cubed over 3 derivative of x to the 1/3, increase the power by 1, 1 over 3 plus 1 is 4 over 3, divide by the same thing. And then x to -1. We cannot use the power rule, typical power rule. If we increase the power by 1, that gives us 0, cannot divide by 0. So in that case, use different set of rules, which is this. And we have ln of x. And ln of x, if x is negative, it will be undefined. So to make sure that it's positive, put an absolute value in, and then all the integrals, all the antiderivative, so just plus c there. Right. So to avoid confusion, I'm going to go a bit slower here. So first we have 3 at the bottom, right? So that 3, instead of divide by 3 at the bottom, this 3 I will write as instead of divide by 3, multiply reciprocal 1/3, and then x to the 1/3. I mean x cubed, sorry. Next, we have 4/3 at the bottom. If we want to get rid of, move that on the top, that will be reciprocal. And x to the 4/3. Then we still have 5 ln of 5 ln of absolute values of x plus c. Right, 4 times 1/3 is 4/3. And then minus 3 over 4 x to the 4/3 plus 5 ln of absolute values of x plus c. Right, so just have that. Next, we have sine x, cosine x, and e to the x. So we'll just take derivative term by term. Derivative of sine x is negative cos. I mean, this is antiderivative. Sorry. Integral of sine x is negative cosine x. There's a 3 in front of it. Integral of cosine is sine. And integral of e to the x is e to the x. And then all the antiderivative to plus c for indefinite integral. Right, and the rest is simple. 3 times negative, so let's make negative 3 cosine of x plus 4 sine x minus e to the x plus c. So that's all. I have a little note here. Also similar what we have on the derivative. This time we have the integral. So let k be a constant. So for constant k, now I will not write everything, but just get the idea. So integral of cosine, I just put the parentheses, kx is going to be integral of cosine is sine, but we will multiply by, instead multiply for derivative, it's going to be divide. Right. I'm not going to write out everything, but we just get the idea. Sine of kx integral of sine is cosine, negative cosine, that is. But we will divide by k. And then we have the tangent and everything. But like I said, not going to write everything. Integral of e to the kx is e to the kx divided by k. So what if we have tangent? Is secant square and divided by k. If that is the derivative. But for tangent, what do we have for tangent? Tangent integral is secant. So it's going to be ln of secant, sorry. So ln of secant of kx and then divide by k. Of course, just divide by k. And then plus c. So the characterization of derivative is multiply, and the integral is divide. Right. I just want to put the parentheses back in here, so it will be consistent to what we have later. So for derivative, we multiply. For the integral, we divide. That in general. If we have a constant, multiply by the variable. Right. Right. Now, we go to the examples. Continue on the example. Right. So all the rule of the integral that we have up to this point over there. Just like when we mentioned about the chain rule, it is too important and too fundamental. So it's not even in the formula. Just more like the way we do it. And the way I do it is first I will look at the problem and then determine what will be u. So in this case, when I look at this problem, u is going to be 2x to the 4th plus 3. So use that inside the square root. So similar to the chain rule, we put the box or the parentheses around it. So what in the parentheses is kind of like what we let equal to u. So inside the parentheses, under the denominator, under the root, in the argument of sine, cosine, or n the exponent. So kind of like the chain rule. Right. So that's what we have, u. So the first thing in substitution, we need to know what is u, and then we can take derivative of it. Because after we need u, we're going to need to solve for dx. So we need those two things. So derivative, I will write du over dx because we need dx. So I write the notation du over dx instead of u prime. Derivative of this is ax cubed. And then we can move the dx over. And then we can divide by the ax cubed over. So du over ax cubed equal to dx. And that is going to be dx. So we have u and we have dx. And then we can substitute back into our problem. So we have x cubed still there. Square root still there. But what inside is going to be u. And then we have dx, which is this. Cancel out the x cubed. And then we have the 8 at the bottom. We can bring down any constant. This one at the bottom, so let's move out, but keep that at the bottom. So we have the 8 at the bottom. Just put 1 on top, so we have fraction, right? And what's left is just square root of u. And to integrate for this one, we use power rule. Rewrite the square root as 1/2 and apply the power rule. Increase the power by 1. 1/2 plus 1 is 3/2. And then divide by the same thing. Right. Next, we have 1/8. Divide fraction is multiply reciprocal. 2/3 u to the 3/2 plus c. 2 over 24, which is 1/12. So 2 and 8 cancel out. And 4 times 3 is 12. U to the 3/2 plus c. And finally, u is 2x to the 4th plus 3. So we have 1 over 12. U 2x to the 4th plus 3 to the 3/2 plus c. Right. So this is a simple substitution. Right. Next, we also use substitution on this one. Once again, like chain rule substitution, what we let inside the parentheses or what we let equal to u will be inside the parentheses, obviously under denominator, inside of the root, and inside the sine, cosine, or any trig function on the exponent. So here we have under denominator, so that typical 3 minus x squared, so let that equal to u. And then we're going to solve for the x, and then we substitute it back into the problem. So u is 3 minus x squared. Of that is negative 2x squared. I mean negative 2x, sorry. And then move the dx over. And then divide by the negative 2x. Equal to dx. So that we have for dx. So a typical substitution problem. We need u and then we need dx. Then we can substitute back into our problem. For x still there on the top. The bottom, 3 minus x squared is u. Dx is du over negative 2x. Right. We can cancel out the x. If the substitution works out perfectly, there will be no x left. It's only u. We can take our own constant. The 4 on the top, the negative 2 at the bottom. So 4 on top, negative 2 at the bottom. So when we do that, we only have u left, and then du. just need to put 1 on top. 4 over negative 2 is negative 2. Integral of 1 over u, or u to negative 1, that is the reciprocal function. So just ln of absolute values of u plus c. And so we just have negative 2 ln of 3 minus x squared, then plus c. So that all. Right, next, more substitution. Inside the parentheses, let that be u, and we're going to solve for the x. Typical problem. So let u equal to 5x squared minus 2, and then to solve for the x, we need the derivative. So du over dx. Derivative of that is 10 x squared. Move the dx over, and then divide by the 10x squared. So we have dx. And then we'll substitute into our problem. And we have x. Sine of 5x squared minus 2 times sine 5x squared minus 2, that is going to be u, and then dx is going to be this. It's 10x, not 10x squared. Sorry, that is the derivative. Right. So we know that because it could not be x squared, because if everything works out perfectly, we're supposed to cancel every x. If that one x squared, it doesn't work. Right. Sorry about that. Right. So we cancel the x. There's still the 10 as a constant at the bottom. So move out sign of the integral. Stay at the bottom. Equal to. Put 1 on the top to have a fraction, and after that we have sine and du, sine u du. So I have 1 over 10. Integral of sine is negative cosine. And then we have negative times 112, so negative 1 over 10. And then cosine, instead of u, we substitute back 5x squared minus 2. Plus c. So a typical substitution, what we let equal to u, when we take derivative, we will cancel with the x, whatever left in the problem. Right. Next we have the problem with definite integral with the limits. Right. So we do similar thing. We're going to solve for let u equal to that, and we're going to solve for the x. So let u equal to x plus 1 and then we'll take derivative. Derivative of x plus 1 is 1. Move the dx over, so du is equal to dx, or dx is equal to du. So that's simple enough. So we have u and we have dx. Now in this form, it is a definite integral, so we need to have the limits. So originally, the limit we have x dx. So the values of 0 and 3, those are the x values. So x equal to 0, so x equal to 3. So if we have the integral of x, that's what we have. But what we have is u is equal to x plus 1. So if we have a little table here, draw u is equal to x plus 1 when x equal to 3, u is equal to 3 plus 1, and when x equal to 0, u equal to 0 plus 1. So instead of go from 0 to 3, it go from 1 to 4. Right, now we have everything. Now substitute back into our problem. First, now since we're going to substitute into in terms of u, so we can, I'll worry about that later. Square root x plus 1 is u, and dx du. Simple enough. The limit though, in terms of u, instead of go from 0 to 3, equivalently u go from 1 to 4. So u equal to 1 to u equal to 4. So this way, when we do the integral, we do not need to go back to x because we have the limits for u. Right, now just integrate. I will use power rule. Now if it is clear, we do not need to write u equal to, just say the numbers. Square root of u, we write that as u to the 1/2. So we integrate. I don't know why I write 3 there. So be 4. So those are the values of u. Now we integrate. U to the 1/2 integrals u to the 3/2 power divided by the same thing. Plus c. If it is indefinite integral, this one we have the limit. So we have 1 to 4. Right. So if we want to be clear, just say from u equal to 1 to u equal to 3. I mean 4. And then 3/2 at the bottom multiply reciprocal 2/3. Like I said, if it's clear, we just don't need to write u equal to, we just say 1 to 4. Right, put in the upper limit, put in the lower limit, and subtract. Upper limit and lower limit. Right, 4 to the 3/2. So 4 to the 3/2. So we can write power on the top on the top is the power, and 2 is the index of particle. So we have this 4 square root of 4 cube. 4 cube is 64, so we have square root of 64. So we have 64, which is 8. So this is 8. So we have 2/3 times 8, and 1, 2, 3 have 1 raised to any power, still 1. So 2 times 8 is 16, so 16 over 3 minus 2 over 3, so that is 14 over 3. Right. So that is the substitution problem for definite integral. So what we do is, if there's a limit, we change the limit into u. So when we do this, we do not need to substitute back in terms of x like we did here, because we have the values for u. So we're just going to substitute into that. Right. More examples. Right. So we have this. So we have integral of e to the x is e to the x plus c. But this time we have something else, so we'll let that be u, and then we're going to solve for the x. This one also have the limit, so we say x equal to -1, x equal to 2. Right, so we start with u equal to 3x plus 4. I just say let u be 3x plus 4. Yeah, because when I write like this, I use different colors, so if we don't have color, it's useful to write that out. So u is equal to 3x plus 4. We'll take derivative to solve for the x. Derivative of this is just 3, move the dx over, and then divide by 3. And so every substitution problem, we need to have u, and we have dx. Right, and now we have the limits. X, and then u equal to 3x plus 4. X equal to -1 to 2. Put 2 in, 3 times 2 plus 4, so they're going to be 10. U is 10. Put -1 in, 3 times -1 plus 4, so 3 times -1, -3 plus 4, so it's just 1. So x will go from 1 to 2. And we substitute into our problem. Right, so integral x equal to -1 to x equal to 2. Yeah, worry about the limit later. A to x plus 4, so that is u, and dx d over 3. Right, now we have u instead of x, and when x equal to -1 to 2, we go from 1 to 10. So we'll say u equal to 1 to u equal to 10. Right, and there's no x to cancel, but there's a 3 here. Move outside. and then we have 3 at the bottom. Put 1 on top to have a fraction. Right. If it is clear to the context, u is 1 to 10, we don't need to write that. We just say 1 to 10. 3 goes outside, so this is e to the u and du. Integral of e to the u is itself e to the u. I should say e to the u. Derivative and integral is the same thing. Also e to the u. Right. Limit u will go to 1 to 10. So we're going to put 10 in for u and put 1 in for u. So upper limit, subtract the lower limit. E to the first is just e. So we say 1/3 e to the 10 minus 1/3 times e. We can factor out 1/3 if we want to. Right. So that's what we have. Next, we have that problem. So a typical problem is, I'm not going to write here directly because it is wrong. So if we go ahead and we use substitution, let's say, don't write this down on the note. If we let u equal to cosine of x minus 1, then we have derivative, which is perfectly fine here. Is negative sign, and move the dx over, so and then divide back by the negative sign x. And substitute back into our problem. Now when we substitute back into our problem, say that one equal to 1 over u, and then du over negative sin x. Now that is the big problem, because negative sin x cannot really do anything there, because we're supposed to cancel out the x. Cannot do that with the negative sin x here. So if we cannot do that, what we can do is try something else. So substitution on this problem does not work. By the way, this problem is a little long, so I will just fold the page in half. Right. So what I do is try something else, and what we're trying is actually a typical thing to cosine of x minus 1. Not really simplifying. What we can do is can multiply the top and bottom by the conjugate. So if that is minus, we multiply by a plus. So if our problem has the plus, we multiply by minus. If we have minus, multiply by a plus. So we have to do the same thing, top and bottom. And then there's dx. So this is not a substitution problem. We show that substitution here doesn't work. Right. Now multiply it out. Cosine of x times 1, so we have cosine of x plus 1 on the top. At the bottom, multiply it out. I just want to multiply it out. Cosine square plus cosine minus cosine, and then minus 1. cancel out. So we have cosine of x plus 1 on the top. And at the bottom, we have cosine square minus 1. Right, so how did that help us? Now, in trigonometry, usually when we have sine and cosine, sine square and cosine square, that is the Pythagorean identity. So cosine square plus sine square is equal to 1. So if we need cosine square minus 1, just minus 1 on both sides, and then minus sine square on both sides. So we can write cosine square minus 1 equal to sine square. Remember, we minus sine square on both sides, so that should be minus sine square, right? So minus 1 on both sides, minus sine square on both sides. That's what we have. So we're going to say cosine square minus 1 is sine square, which we substitute into here. Right. Now if we just say equal to, that would be rather confusing. We'll use this a lot later, so we just say this integral equal to an integral I, and we'll continue from there. And we say 1 over cosine of x plus 1 over negative sine square and then dx. Here we can split cosine over negative sine square and then plus 1 over negative sine square. Right. For that one, let's just rewrite. I will take the negative outside. That's negative goes outside. And cosine of x, and I will write as cosine of x over sine x. And then I will have another sine x. But there's nothing on the top. Still need to put 1 there. And then 1 over square, so that is cosecant square. Remember, we take the minus outside. So here we have cosine over sine, which is cotangent. 1 over sine is cosecant. So cotangent, cosecant, or cosecant, cotangent. The reason I write cosecant, cotangent, because the integral for that is negative cosecant. So that is equal to cotangent cosecant. Integral cosecant square negative cotangent sorry. Right. Cosecant square integral of that is negative cotangent, and integral of cosecant cotangent is negative cosecant. So negative and minus a negative, that's a plus. Negative, negative, so that cosecant. x plus cotangent x plus c, right? So not a substitution problem, just a bunch of trigonometry. Right, next we do this one also. Yeah, what can we do here? So a typical thing inside a radical, so let that be u. So we do that, and then we take the derivative, and then we can solve for dx. Right, so that is the problem. Alright, so we solve for dx. Derivative of x minus 1 is just 1. Move the dx over. So du is equal to dx. That's simple enough. Now let's substitute back into our problem. That one equal to still have 3x on the top. The bottom square root x minus 1 is u, and dx is du. So that integral equal to this. Simple enough. The problem here is there's an x left. So like I mentioned before, if it works out, all the x supposed to cancel, to only have u left. Now there's the problem, but an easy problem to fix, because we did have u equal to x minus 1. So in that case, if u is equal to x minus 1, we can solve for x easily. Plus 1 on both sides. We can say x is equal to u plus 1. So plus 1 on both sides. And we have x is equal to u plus 1. So I substitute back into the integral. U plus 1 for x. Square root of u du. Right, so this is simple enough. The 3, we can take it outside of the integral. This is a little long, so I try to keep 3 on the outside. And I will split the integral u equals square root of u, and then 1 over square root of u. I will split the integral. Right. And then still have 3 in front. U, square root of u, we can say u to the 1/2. So u over u to the 1/2. And then plus 1 over u to the 1/2 du. Now, u over u to the 1/2, where we divide fraction. Divide two things that have the same base, a b. Subtract the exponent. So we subtract by default. This is to the first power. So 1 minus 1/2. 1 minus 1/2 is 1/2. And this one move to the top. Negative 1/2. right? Now 3 u to the 1/2. Now we integrate u to the 1/2. Power rule says increase the power by 1. 1/2 plus 1 is 3/2. Divide by the same thing. Increase the power by 1. Negative 1/2 plus 1 is 1/2. Divide by the same thing. Right, next. Divide by 3/2. Multiply reciprocal 2/3. And then u to the 3/2. Then plus 1/2. Reciprocal is 2. And then u to the 1/2. Let's see. Right, 3 and 3 cancel out. Now we multiply it out. 3 and 3 cancel out. We're going to have 6. I'm sorry. 3 and 3 cancel out. Is 2 left. And then u to the 3/2. And then 3 times 2 is 6. U to the 1/2. Plus C. And the last step is plus 6 x minus 1 to the 1/2 plus C. Right. So sometimes when we do the substitution and there's x left, which we can solve easily, and that the last one we have was this one. We cannot solve for x easily here. We cannot write that in terms of u easily, so that doesn't work. Right. So that's how we do the problem. Right. So that is the review for calculus. After this, we'll start calculus 2. We start from the section 7.5. So until then, thank you for watching.